Hi everyone. This video is going to be talking about stem and leaf plots. A stem and leaf plot is something that is very practical to organize your data if there's a lot of data to look at. Our example today is only 7 numbers, so it's not quite as serious as when we get into our monthly temperature work. When we have 30 or 31 numbers to look at, it's so much easier to organize it. And the stem and leaf plot does that for you to find your landmarks of range, mode, median, and mean. So a stem and leaf plot is organized by sort of like a T formed. So you form this T with a vertical long line, and then you put a horizontal line up towards the top. And on the left side of the vertical line, we call this the stems, and then on the right are called the leaves. And so a leaf is always the least digit of your data numbers. So in this case, it's all the ones, the 8, the 2, the 3, the 5, the 2, the 1, and the 5. If we're talking about decimal numbers, it would still be the same least value to put as your leaf. So say we had decimals between the 1 and the 8. The 8 still is the least value, and the 2 has a decimal between the 2's. The 2 is still the least value. So whatever is the least value becomes a leaf. And then everything else, if there's triple digits, quadruple digits, all those, whatever isn't the least value becomes the stem. So we organize it all by that least value of that data number. So what we do is we look for what is going to be the stems and put them numerical over here on the left. So what I'm seeing in these 7 numbers, that 20s, or the 2 of 20 is the greatest stem value. So I look for the least, and because we're going to go numerical, we're going to start with the least. So 2 is going to be the greatest. Well, is there any single digit numbers here? No. So the teens would be my first stem. So the teens, I see some teen numbers, so that's my first stem. And then we said there were 2's. Are there any 30s? No. So it's going to be 1 and 2 as my stem. Now I'm going to organize my leaves. And my leaves always start from least to greatest as I go across. So this is where we start canceling things as we use them up. So I'm going back to the teens, and what's the smallest teen number I have? Well, there's a 15. So I put the 5 there. Now you can see that's a 15. And then I can put a comma there if I want to separate them. But always remember there's single leaves, so it depends on if you want to put separation there. You sure can, but you don't have to. And then I look for the next value that's after a 5 in the ones place, and I have another 15. So I put that next 5 there. And then what I'm looking through, and I go, oh, wait a minute. I made a mistake. All of a sudden I see this 12 sitting there. Oh, that's smaller than the 5. So sometimes I have to go back and erase and maybe start over. Or if I can squeeze it in, I can do that too. But with my eraser, I can easily do that. But if you use pen, see, then you're stuck. So always use pencil. Maybe I need to erase it. So I go back and say, wait a minute, I had that 12 there. That's a 2. Now I can go back and do my 5's. And then I look for, is there any more teens? Yep, I got an 18 over here, so there's my 8. So 0 is always the least value, so if I had it like a 10, that would have went first, the 0. But now I have all my teens done. Now I drop down to the leaf, the 2, the 20s, and I find what is the smallest 20. I have a 21. I see a 22. And I see a 23. Now, what is a very good check? Always do this. Do I have everything? What if I didn't see that 12 earlier? And I would have checked by, do I have the same amount of leaves as I have for data? So we said there's 1, 2, 3, 4, 5, 6, 7 data numbers. Well, I need that same number of leaves. 1, 2, 3, 4, 5, 6, 7. Okay, I have recorded in my stem and leaf plot everything that was a data number. So I'm in good shape. Now I'm ready to look at my different landmarks. So again, range, I should be able to find, And what I can do here is I look at the least valued number up there in the upper left-hand corner. That's a 12. And what's the greatest number is always over in the lower right-hand corner, and that's a 23. So if I subtract those, I get the value of 11 as my range for this data. And again, where's my least value? Always the upper left-hand corner. What's my greatest value? Should be the lower right-hand corner. I subtract them to find range. What's my mode? Well, again, I can just look at the leaves. I don't have to go back to this original data and try to sort everything out and see what I can find. I can look at my leaves. Well, I look at my first row, and is there anything duplicated? Oh yeah, the 5s. So I see 2 5s, so that means there's 2 15s because of the 1 as my stem. Is there any more there? Well, I'm going to put that over here so I can remember it, and then I look for any other duplication of leaves. Nope, there is no other duplication. You're saying, well, wait a minute, there's 2 2s. But this is a 12 because of the stem, and this is a 22. So if they're not in the same row, they're not a duplicate. So in this case, the 5s were in the same row, and here the 2s were in separate rows. They're not duplicated. So there was only one set of 15. So there's my mode, because there was 2 of them, everything else was individually. And then I look at my median. Okay, how do I find median? That's the middle value. Not up here. We're not looking at the original. We're looking at the leaves again. Now, what can I do? I can do this. I can process and go, okay, I'm going to cancel this guy and this guy. This guy and this guy. This guy and this guy. But that can get confusing if I cancel that way on a stem and leaf. The best way to do it is say, how many total leaves do I have? We had 7. What is half of 7? So if I divide 7 by 2, I get 3.5. So I have to go and count. I have 3 leaves, and then that half is the data I want to look at as the median, because there must be 3 leaves on the other side. So if I count, and always count left to right, top row first, 1, 2, 3, and 0.5 would mean it's that next leaf, because notice there's 3 leaves down here coming from the higher end of the values. So there's 3 at this end, 3 at this end. That means that 8 or 18 is my median. So when it's an odd number, you're going to have a 0.5. Well, what's that whole number? You want to count that many leaves. So in this case, 3.5, I count 3 leaves. 1, 2, 3. And that next leaf is my median because it's 0.5. And that should come out right because there should be 3 leaves on the other side of the 18 down here. So median 18. That is the quickest way to do it. Just take your total leaves, divide by 2, and then you know where to count. You don't have to cancel out because that gets confusing with a stem and leaf. Mean, again, I have to add up. Now, with mean, I would go back to the original data because this gets confusing trying to add these numbers up, always remembering your stem to go with it. So I just go back to the original numbers and add them up to get a sum. And in this case, it's 126 as the sum of these numbers. Don't worry about it from the stem and leaf. Just add your data up. Doesn't have to have a certain order, just add them up. And I get the 126, and there's 7 of them. And so when I divide 126 by 7, I get 18 as the mean. So that way, don't worry about this when you find the average because it's really confusing. Go back to your original numbers, add them up, and then divide by your total leaves. Again, you can think about your leaves. You have 7 leaves, divide that, and then you get your mean. Now, what if it's an even amount? So let's take off the 18. Now we have an even amount of numbers. This 18 disappeared here. So now I have this even amount of leaves. And when I say, okay, how many leaves do I have? I'm going to say 6. 6 divided by 2 gives me a number of 3. Now that means that's the front side of the median of minimum numbers or least amount of count of value of numbers, and then I must have 3 on the other side if I divide it by 2. So I count 1, 2, 3. and then there's 3 down here. So someplace, whether you think of the median here or the median here, it doesn't matter because it's between this 15 and the 21. That's my median is between there someplace. So again, what I have to do is take that 15, add it to the 21, because those are my numbers where my median's between, add them up, that's 36, and if I divide by 2, 36 divided by 2 is 18. And so my median is 18, a number that is not there in my data. If you have even amounts of data, your median is not one of the data numbers. That's a key thing to remember. The median will not be one of your numbers. Now, it's coincidental that it turned out to be the same median as the other numbers. But notice, 18 is gone. It is not there now in those 6 numbers. But yet it shows up as the median value because it's between 2 numbers. When there's an even count, your median will not be a data or a leaf. It's going to be something different between 2 numbers. So stem and leaf is a great way to organize. And when you're looking at the leaves, there is always one leaf, and that's the minimum number on that data. It's the least value, I should say, of that data. So in this case, it was 2s. If you have decimals, it's still what is the least value of your decimal place value. So it can be triple numbers, but it's still the first digit, and you have then leaves that have more than 1 digit. So it doesn't matter that way. It's still set up the same way. So if you have questions with stem and leaf, it is new. Practice on IXL or ask questions or watch this video several times and hopefully you can understand it. But always start at minimum and work down. Minimum and work across. If you reverse it, it can cause you problems. So always remember, it starts from minimum and goes to maximum.